Thank you very much. Thanks everyone for being here. Thank you, Maria. Thank you, Paolo, for making this happen. I'm Alejandro. I'm going to talk to you about signal processing and political speeches. So I'm going to try to convince you that this is not only novel, but also kind of productive way of studying political speeches. I'm going to try, and then we see what you think at the end. And I'll tell you a little bit more about myself. So thank you very much, Paolo, for the very generous introduction. As Paolo mentioned, I have a bachelor's master's in psychology, also a PhD in management, and during my PhD, I started to work a lot with text, which is how I got to meet Maria during the summer school in computational social science. Back then, we worked on a paper on the Great Resignation, understanding the language in Reddit of what is it that people express when they were talking about quitting. Then I also moved to work with word embedding. So this is from a paper that is in the second round R&R in research policy about how people in online communities might kind of travel different cognitive pathways when they ask questions and when they get different type of answers, and how that kind of maps into giving back to the community. But then those approaches I started during my PhD. Then I started to move a little bit more towards the conceptualization of human beings as kind of these dynamic entities which are in constant exchange with their environments. And this is how I got to write this fellowship project, which I'm going to talk to you a little bit more about right now. Now, why crowds? Why study crowds? I'm going to present you a couple of quotes, and without the intention of putting anybody on the spot, I'm just going to ask whether you know who said it. This is the first one. If the play has been a good one, then please clap your hands and let me leave the stage to the sound of your applause. Has anybody heard this quote before? Don't worry, it's kind of obscure, but it's the last words of Caesar Augustus before, the last words then before he died, right? So, so what happens? This Caesar goes out of this world thinking about the stage, the crowd, the clapping, the glory, if you will. And then I give you other words, which I think are a little bit easier to guess. They corrected me, everything I said, practically, I think 9 times or 11 times, and the audience was absolutely, they went crazy. Who do you think said this? Exactly. This is Emperor Trump, 2024. Now, the funny thing about this, or what I consider extremely funny, is that there was no crowd. This was a debate that he had with Joe Biden where there was no audience. So, what I'm gathering from this is that across time and space, political leaders seem to really care a lot about crowds, even if they don't exist. So the question that I asked myself in this fellowship, well, what happens when they get their support? So instead of asking what do they do to get it, is like, what does that do to them? So the fellowship that I am doing at Imperial, for which I was sponsored by Professor Sonesta Laifar, is about the rhetoric of autocratic leaders, with the idea of understanding how the crowd reactions, such as clapping, booing, and so on, map into the actual speech, like saying, okay, the person starts to talk for longer about something, and trying to understand whether that helps us understand for example, the very violent rhetoric of Donald Trump. So is this basically just people pleasing and then kind of progressing on this pleasing, because at some point the crowd gets bored of the same things, and then he has to be more and more and more extreme, right? And so answering this question required me the way that I want to do it, which is kind of quantitatively and kind of a large scale, requires data on the timing. So when did people react, for how long, and the intensity of crowd reactions. So what's in the toolbox of social sciences for this type of question? Well, the first element in the toolbox of social sciences are qualitative analysis. So this here is a very good example of actually pretty good qualitative analysis. So where they analyze the speech of Trump, the one that led to kind of the Capitol. Well, everybody knows what I'm talking about. And they did a really, really neat analysis where they looked at kind of the whole context. So not just the speech, but what was going on around it, what was the situation in the US, et cetera, et cetera, et cetera. So qualitative analysis kind of allowed for this very deep, in-depth, rich type of insights. Here they use it to understand how they together create kind of a shared social identity. The second tool is human annotator. So this is a very old paper, mostly from the 80s. And here people will literally sit down to listen to speeches and to transcribe them and to say, okay, how did the audience react, but also what was said, and whether like the intonation, whether it was louder, less loud, and so on, and to understand what are the type of messages which kind of elicit these reactions. The third tool that we have are third-party transcripts. So this is a pretty good paper from not too long ago in political science, which uses data which is already existing. So Germany has very good transcriptions of speeches. So basically they provide you already with that. So there's stenographers that are like writing everything that is happening and also how the crowd or how people are reacting to that. So for example, they discover that women get more clapping, but less cheerful kind of reaction. So this was a gender paper. Now, for my specific purposes, these three methods have strong limitations. So qualitative analysis do not generalize, because that's not the point. Human annotators are costly, and you cannot eliminate the subjective component. So, for example, is it loud or not loud is going to depend from many factors, not only that differ across people, but also the same person is going to be like influenced by a bunch of things, right? Third-party transcripts do not give me duration or intensity, and they're also limited in the sense of you can only study those specific environments which give you those rich transcripts, which are basically Germany. So, you know, I having lived 9 years in Germany, I can tell you that if there's one thing that Germans do really well, is data. They're really, really good at that. And then there's general limitations, which are basically that they don't scale, any of them. So what happens if you want to study a political speech in Argentina? What happens if you want to study a political speech in France, and so on? None of these methods can scale to something like that. I mean, you can still do, of course, qualitative analysis and so on, but it's not going to give you this kind of rich of insights across them. So social science methods are suboptimal for my goals, and they available, and here emphasis on available, computational tools too. Why? Because if you Google, you're going to find that there's a bunch of experiments where they train neural networks to like understand our reactions, and they work generally pretty well, but they're not available. So if you search for them, and there's one, for example, one foundational model called JAMNet that you can use to label, but it's not, you still need to fine tune it. So nothing that is kind of off the shelf can be used for these purposes. So for example, one that I originally planned to build on has the issue that it relies actually on the language, so on what the person is saying, kind of predict the applause. And the problem with that is that because my interest is in the language itself, then I'm basically kind of putting my dependent variable inside the computation of my independent variable, which kind of makes things a little bit messy. And then it's also about clapping, and I'm going to show you a video right now.
Should I run again? You tell me. There's your controversy right there. There's your controversy.
So, how many claps were in this clip? 0, exactly. So a binary classifier of clapping is going to say nothing happened here. But we all saw and we heard that the crowd was completely in some type of ecstasy, right? And so what to do? Well, the first thing I did was to ask around. For example, perhaps Maria remembers when we were in the summer school and I was like, Maria, do you know anybody who works with sound? And actually I realized that this is a very rare profile. Like it's not so common. For me, when I started this project, because there's so much kind of sociological research from the 80s on these, I thought, well, there must be so much stuff going on for this, but actually not. And then I asked one of my mentors, Professor Amir Goldberg, who is the co-lead of the Computational Culture Lab at Stanford, and he told me, Alejandro, I don't know anyone who works directly with sound, but this seems like a good opportunity to innovate. So why don't you talk to the experts? Why don't you talk to the people who work with music? Why don't you talk to the people who work with this kind of analysis of acoustic features? So the first person I contacted was Professor Pat Savage, who is the director of the comparative music lab at Cairo University. He has several of these type of studies that understand kind of the acoustic regularities of music in the world, like across cultures and so on. And he told me, well, the right person for you is Professor Emmanuel Benetos, who is a colleague of the machine listening lab at Queen Mary University here in London. And so basically I went, in a world trip all the way back to London. And this helped me to start to work directly with the sound waves with guidance of an expert, because as you saw, I'm a social scientist. So 1 year ago, I hadn't heard the term signal processing, and now this is what I do every single day. So I'm going to show you what I did. What is it that I'm doing, and then let's see a little bit of the challenges that are still there, and what is this good for? So, anybody here has worked with sound? Good, because then everything is going to be new for you. So that's very nice data. So this is how a sound wave looks like. This is
like a return time series.
I'm sorry?
It looks like a return time series in finance.
Well, I guess you could say that. But yeah. So basically, I mean, perhaps that's a good analogy in the sense of sound is continuous. So you're always working with continuous data. And for what I understand, actually, there's some research, please correct me if I'm wrong, using, for example, Fourier transforms and so on for financial type of, yeah. So basically, it's understanding of waves, right? So basically, this is a sound wave, and the sound wave of the clip that I just showed you. So a very nice property of sound and of any wave, actually, is that you can separate it into the waves that compose it. So usually what you would get when you record something with a microphone is just like there's kind of this little recoil inside the microphone that kind of moves according to how the air pressure is pressuring. It's actually very simple. And this is going to transmit a bunch of information, which you can then separate into all the individual frequencies that created that. So this is a Fourier transform, and perhaps unusual for your group, this is the only formula you're going to see in my presentation. So that's why I prepare all of these formulas for you here, so you don't miss them. So why is this a good thing? So once you apply a Fourier transform, basically what you get is the spectrogram. And the spectrogram, an easy way to understand it is like you're taking the sound wave and you're looking at it from above, and then that separates it into all the individual frequencies that are present there. And this is very useful because certain sounds have certain patterns that you can find in the spectrogram. And one of the most studied patterns in this area of study is the human voice. Why? Because everything works with voice commands, Alexa, your phones, anything you can think of. So there's a lot of really, really, really well-developed algorithms to work to denoise speech. So basically, I put this through a speech clean algorithm, and this is the result.
Should I run again? You tell me. There's your controversy, right? There's your...
So this is pretty good. I got the speaker, but where's the crowd, right? Now, because of the same principle, you don't need to kind of apply the algorithm in reverse or anything. Everything you need to do is to take the sound wave that you obtained from the speaker and subtract it from the original wave. Like it's literally one line of code. And what this gives you is this. Like crazy in the last months, and people go completely nuts. Like it's crazy. So sounds pretty good until now, but there's still several challenges. So let's jump into what do I need to do to make this useful. The number one is that there's some artifacts. So I don't know if you realize, but at the very beginning, did you hear that? That is simple. It goes for Donald Trump there, that's the echo, because the speech algorithm works out pretty well. That means that it can separate it separates the most perfectly preserved speech and kind of cuts it, and the echo is left as noise. But that's problematic for any type of analysis because it will give you some biased features, right? This is also very hard to deal with. Like there's a whole area of acoustics that works on de-reverberation, which basically is this. An easier way to work with is to have some robust output, which kind of only takes reactions above a certain amplitude. Now, this is useful for speeches which are in kind of nice conditions, but the worse the conditions, the worse the echo is. So there's speeches where the echo literally like sounds almost like original speech. And yes, maybe you will think, oh, well, then just run it again, but it doesn't work because echo has a different, like it bounces over the walls and just, it's not picked up by the algorithm anymore. The second problem is a little bit easier, which is that there's misclassification of the crowd as being part of the speaker, because sometimes people scream something and they scream it so loud that it's actually recognized as human voice. But this is easier to solve.
Should I run again? You tell me.
You can use speaker diarization, which are also very well developed algorithms, which basically tell you who's speaking at which moment in time. And then basically, if it gives you, okay, there's two speakers here when it should be only one, well, basically the second speaker, just take away that out of the wave and put it into the noise wave. So those are not so problematic. The third one is a little bit more problematic, and it is that crowds, until now we have assumed that everything is good, that everything is positive, but crowds not only are supportive, right? If a crowd doesn't like something, what are they going to do? Usually they're going to boo. So they're going to somehow express this anger, and it's usually going to be through booing, which is the only unified, measurable adversarial response that we know of in social science. Doesn't mean the only one. People can scream, people can throw things, and so on, but it's one that we know that happens in many places. So parallelly to the main project, I'm solving this by actually training a booing classifier from scratch, which is kind of a CS acoustics paper with Emmanuel and his team. Okay, so then I thought, okay, well, after I solve these issues, then I'm going to have the coolest tool for social scientists out there. It's going to be amazing. It's going to like give features on the timing, intensity of both the speaker and the crowd, and it's also going to give a bunch of acoustic features, which are useful for all types of analysis that you can think of. And this is what happens when you've been working on something for months and months and months and months, and you haven't talked to the social scientists. Then I went to the social scientists, and everybody absolutely loved it, but they told me, but this is brutally complex, man, for social scientists. I don't know for you. So not so fast, not so fast. Why don't you first validate? Why don't you validate these with your own ideas, with your own kind of projects, and that way you show that there is value on this type of method. So what I'm going to do right now is to present you a couple of ideas that I've been thinking of in order to validate this, and I would love to hear your feedback on what do you think about them. Where do you think there's other? As I was literally told, it was like low-hanging fruits. So someone who does a signal processing approach to crowd reactions is not someone who's very good at picking low-hanging fruits, right? So perhaps you're better at that than I am. So the very first of these is the sound and evolution of hope in political speeches. So I don't know if you have read these type of papers, but for example, there's kind of a trend on understanding through long analysis of very long time spans of data on how certain emotions have developed and so on. So one of them is about news headlines and tells us that they have become more negative across time, especially left and right-leaning news outlets, perhaps unsurprisingly, have kind of started to go down the sentiment score. And fear has started to raise across time. And there's also this other study which shows us, this was just featured on The Economist a couple of weeks ago, but popular music has become more negative across time. So basically, same thing. I mean, they did a little bit kind of focus on shocks like the pandemic. I don't remember which is this one, but in the end, we see this trend, for example, on sentiment going down as well, right? And stress kind of going up, which is not exclusive to pandemic times or to like shock times. And so what's going on? One answer comes from Neutral Hand. He's a philosopher who writes a lot of, he's been writing for several years, short essays about contemporary problems. And this is the last one that he wrote, and it's called The Spirit of Hope. And what he basically says is that our society has become hopeless, and that hope is something that rises when despair kind of reaches a limit, like a phoenix, he says. It is hope above all which gives us the strength to live and continually to try new things, even in conditions that seem as hopeless as ours do here and now. So what's the question that I find interesting here? Have we lost hopeful political speech as well? So if I ask you, what is the most hopeful political speech that you can think of? What will be your answer?
I agree.
Right? Most people will think about this individual here, and there's perhaps a reason, right? There's perhaps a reason on why is this so good. So I'm going to show you, this is the analysis of the pitch during the whole speech, so the evolution of the pitch across the speech. And there's a bunch of interesting things here, which are going to like perhaps be more interesting once we see a couple of other comparisons. And we see that it's kind of steadily increasing. And I mean, I'm a social scientist, so here I have to really like tie my hands to the back to not start to run regressions and be like, I discovered the spirit of hope in political speech. But to say, okay, I mean, this is a single example. Let's look at it, let's learn from it, but that's just kind of the beginning, right? Well, we see that the pitch, which is basically how, when we describe a sound, where we say it's high or low, whether it's it basically tells how deep it is, the sound. And what we see is that he has quite some range, so and also very controlled. That's kind of the interesting part here, at least for me. Like we have very little variation, like within the segments, and they start to slowly build up. So how does this sound? Let's hear the first segment.
I am happy to join with you today in what will go down in history as the greatest demonstration for freedom in the history of our nation.
So he is quite low. So he leaves a lot of time among sentences. We see, for example, that the airtime that he takes is like 64.8% of the whole duration, with a median segment of 2.44 seconds. But then what happens almost at the end?
This is the faith that I go back to the South with. With this faith, we will be able to hew out of the mountain of despair a stone of hope.
With this faith, we will be able to hew out of the mountain of despair a stone of hope. So here is where he's actually talking about hope. And we see that he's doing it in a way that kind of reminds us a little bit of preachers, which is not surprised because he was a reverend, right? So this is what I'm interested in. And perhaps we can think of, okay, why does everybody think of this speech, which is kind of old? What about more modern speeches? Anyone?
There are a few long ones.
Exactly. Oh, wait, sorry. How did the crowd react? So now, please take this with a grain of salt, because I literally had to clean these manually because of the issues that I told you about. And here the echo is terrible. Like it's basically like you have 3 Martin Luther Kings speaking at the same time. So I went like, with the software, like visualizing the echo, and I was like, oh, you're gone, you're gone. So perhaps I was a little bit abrasive in the end, but let's hear how it sounds. So there's clapping and there's also voice, while in the other one it was just kind of a very baseline clapping of like, hey, thanks for being here. And then, of course, one can start to think that perhaps one of the ways to work around this is to see the correlation between the two waves and things like that. Now, what about the more recent speech? Well, as you rightfully mentioned, this is the other person that usually will come to mind when people think about hopeful speeches. Now we see that there is also kind of a positive pattern, but a little bit less steep, and with a little bit more going on, in the range. Now, of course, the microphones matter, right? The microphones matter, but at least when it comes to the pitch, it tends to be pretty reliable across, which is why we chose this as our first feature. Like, which doesn't mean it's going to be the main feature. It's just the first feature that we're trying to use to understand this. And now, this is, for example, one of the things that Obama says here, like, do we participate in politics of cynicism or a politics of hope? I mean, I've been reading all these speeches and so on, and I think that he has that punch, but I don't think he gets where Martin Luther King left us. I don't think he did. And perhaps you want to see a non-hopeful speech. How does that look like? Well, I couldn't think of a less hopeful speech than Donald Trump after thinking that he loses, because he loses, and then telling people, hey, we're not going to let this happen, right? And I mean, before you even look at the graph, how much airtime does he have? 80%. So if you listen to the speech, it's a massive, and look at how much it lasts. 71 minutes versus around 16, 17 minutes from the other two. This is just a massive rant. This is a massive, 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 massive rant. And if you see, there's kind of no discernible pattern. I mean, we're humans, so we're always looking for patterns, and we might see that there's kind of like oscillation here, and there's kind of a peak here, and then it kind of goes like this. I don't know. But the point is, like, it's not so easily discernible as in the other two, right? Or especially in the speech from Martin Luther King. Why do I consider this idea a quick win? Well, because the way that I'm thinking about it is by using only the speaker wave to some NLP. So trying to understand, okay, so when people are, so how do I understand when are people giving a hopeful message? Well, by using NLP, and then understanding kind of the patterns on the acoustic features and seeing whether certain patterns, so creating kind of a fingerprint and seeing whether this has changed across time. Now, why not? Well, precisely because this type of analysis of acoustic profiling tend to be quite complex. But, well, I guess in the end, that's also always going to be the case, right? Now, what's the second idea that I want to present to you is, I call it the back validation idea, is crowd reactions on racial bias in policing. So what you're going to see here is taken from Grosjean et al. 2023, who did an analysis. This is published in the Journal of Economic Letters, where she does this analysis where she looks at the probability of being, like, basically the proportion of Black drivers that were stopped by the police before and after a Trump speech takes place. And she finds this increase of 5.75%. She uses 35 million data points, and this is only to Black drivers, and it persists up to 60 days after the speech. And basically, what I think that can be brought to the table here is whether the reactions of the crowd can add a layer of explanation. Like, is it the same if Trump says something incendiary and people are like, "Whoa," versus if they are like, you know, like we saw in the clip that I just showed you. Now, why is this a quick win? Well, because the data is public, and because there's also kind of other validation measures inside it about, like, characteristics of the populations and so on. Why is it not a quick win? Because I will actually need to clean the speeches by hand, which is doable because they're 95, but it still kind of defeats the purpose of a quick win, right? Yeah, so I have some questions for you, which are very simple. What do you think about these ideas? What changes will you make to them? What data would you like to see about idea one? Because, yeah, that's important. Like, in this stage, every single political event that is available online is a potential data point. It's a potential data source. What does that mean? I can use rallies, I can use debates, I can use anything you can think of that is available online. So how do you think this looks like? And perhaps what are other options you can think interesting related to, for example, the expertise of the groups, such as financial markets, such as issues from complexity science. But I don't know.
Why not?